Hello, everyone. Welcome to the third section of lecture one. So here we're going to start to look at some coding aspect and specifically using Python to work with financial data, right? So let's get started. I'm using the Google Colab, which is an online free product platform, which allows us to do coding in Python, right? So if you don't have the Python environment installed on your laptop, you can use this tool to do some coding on the web, and it saves the results up to a certain limit. So let me first restart my runtime, which is to restart from scratch. All right, and let's see. Okay, so so I just run the codes, right? So that's why you see some outputs, but I want to remove the outputs as well. So let me just disconnect and remove the outputs as well. So see if you can remove. Still not removing. Okay, so we'll just go with what we have. So first thing is usually to import some packages, also called some libraries. So these are the usual ones we work with. So this is to work with random numbers generator. This is to work with NumPy formatted data, right? So arrays. So we'll talk about more about it later. Now, first one is random masking, which is essentially how to choose random numbers or random elements from a list of numbers. So here, for example, I'm using this function to choose a random number between the number 0 and 10. If I run it, it shows okay, so I need to import the package first based on the error message I have. So it's not defined, and I'm defining it by import it. So it's being imported. It's returning the number 8. If I run it again, it's gonna be probably a different number, right? Because every time it's random. There's a way to control the randomness, but we'll not talk about it here. So now this is one number, but what if we want to generate a list of random numbers? For example, say 10 numbers. This is how we can do it. So we're going to repeat this action, which is again generates one number 10 times, right? We're going to repeat it 10 times. So this is one way to write it. So this is called a list comprehension. Basically means that for each number in this range. So what is the range? So this range is returning us the numbers from 0 to 9, right? So if I have a separate code block here and then return it. So it's going to return me a range, but we cannot tell it. So let me convert it to list. So what this essentially saying is that want a list of numbers from 0 to 9, which happens to be 10 numbers. So in Python, the indexing starts from 0, right? So it's 0-based indexing, and the last number is usually not included. So it's only lasts until 9. But in total, we have 10 numbers. So this essentially tells us how many numbers we have, right? So we have this number of the length of this list is 10, right? So for each of this number, right? So this is for, it's a for loop. Calling this action, I'm doing this action. So I need, in other words, I want to repeat this action 10 times because in the for loop, I have 10 elements to loop over, right? To iterate over. And then this is square brackets, which is to convert it to a list, right? So that's why you see when I run this number, when I run this code snippets, it returns me 10 numbers, each of which are randomly generated from 0 to 10, right? So from 0 to 9, actually. Okay, so okay, use 10 as well because this is a parenthesis here, so it can be 10. All right, so this is 10 numbers. And what I want to do next is to randomly sample 2 numbers from this list. And I want to do this by index. So what do we mean by index? So index is, for example, The first element is indexed 0. How do I know? If I pass in 0, it's returning me a number which is 5, right? What about this number? This is 0, 1, 2. So I should pass in the index 2. And then it returns me 10 because the index is 2, right? So I want to select the samples by the index. So that means I need to generate index first. And that's why we want to do this, because we want to say when you have a large sized order, or you have lots of orders, and you are splitting it to small sized orders, and you're only exposing a few of them. So, and the rest remain as hidden orders. So this is called iceberg orders. And so the thing we want to do is what orders you want to expose as the tip of the iceberg, right? And first we need to choose the index. So how do you choose the index? So this is the same thing. We are getting the length of the total orders. So this is the number of orders we have, which is 10, and generates a list of numbers from 0 to 10, from 0 to 9 actually. And then we're subs. So this random sample means we're going to random sample 2 elements from the list. So this is a list of indices, right? This indices from 0 to 9. And the return is, let me run again. It's going to return different results. So index 4 and index 6. So meaning we're going to select index 4, which is this one. This is 0, 1, 2, 3, 4, right? This 4, this is 6. And let's pass in to see if it returns these 2 numbers. Yes, it is, right? So this is index 4 entry. This is index 6 entry. So select based on this square brackets, which is to do selection, and transform it to a NumPy array format. All right. So this is a bit of basics in Python programming. Now, next section is about analyzing stock data, and we're going to use the Y-Finance package, which is one of the most widely used package to retrieve and work with finance data. So let me just install it. So this means that we're going to install the package Y-Finance here directly. So this is special notation. Here we just need to run this command, and then it installs. So we can ignore the error, the only message for now. Let me import it. And then what I'm going to do next is to retrieve stock data based on the ticker. So a ticker is a symbol for a company, right? So for example, Microsoft is MSFT, Microsoft, right? We're going to first import the package, and then call the ticker function. So which means to grab the information based on the ticker. So this means we're going to download information and then print out the information of this stock. So this stock means that everything, there are lots of attributes on the MSFT, this object, and then we're going to access the info attributes here. Right, so if I just run it, then it will return me the information about Microsoft. So for example, there's a lot of information here, zip code, sector, etc., city, country, states, lots of information here, right? So this is a very convenient way to collect this metadata about a particular company. They're interesting, right? So one more note is that this format is called a dictionary, right? So it starts with the parentheses, right? And we have the key value pairs. So this key, this is value, this is another key, this is another value. So how do we access, for example, the sector? Then we just pass in the key, and then it will print out the value. So here we want to access the market cap. We just pass in the key, which is also should be here. We do a bit of search. So market cap is here. This is number we're interested in, and I want to return it. So let me run. And it returns me a market cap, which is what we want, right? Next, let me get the get today's date. So This date on package allows me to retrieve the dates in a particular format, which is year, month, and dates, and then I can print it. All right, so I can print it, and then I can use the parameter, this is argument, to specify the end dates. So essentially what you want to do here is to download using the download function, the stock price data for Microsoft. Right, so just run it, and it's going to print today's dates, and then showing that's 100% downloaded for this time period. We can view the heads, which is the first few rows. So this is the first few rows. We can see that this is the price for the price for open, high, low, close, and adjust close and the volume. Right. So this is for first few rows. We can also look at the data in terms of the last few rows, which is by calling the tail function for data. Right. So this gives me the tail, which is the data we have now. This is yesterday's data, right? So I'm recording on 6th January, and this is until yesterday, because today I have not finished yet, so we don't have to take this data. All right. We can check the dimension or the size of the data sets by calling the shape attributes. So this gives me, we have 254 rows or days, and then the 6 columns, right? So this is the number of rows, number of columns. So the rest we're going to plot the data and then analyze a bit. So I'm going to import the Go function, which is from plotd, and it's also a very cool visualization package. We're going to pass in, I want to use the index, which is the dates, and then visualize the closing price as lines. So if I just run it, it's going to plot the stock price as line charts, right? And then if I mouse over a particular point, you see we have the dates and the price. So this is making the graph interactive, right? It's not fixed graph. And we can do more things. For example, using the mouse to highlight a particular range, and it's zoom in. So zoom in, zoom out is a function here, right? So it's more interactive. I can also overlay the trading volume information here. So just by having another row here, this add trees, I'm going to use the bar function here. So there's no need to memorize the grammar here, just understand roughly what it's trying to do. Right? So I'm passing the volume. Again, I have the same x-axis. So x-axis is the same. The y-axis, I'm changing to the volume. So after running it, so we have the outputs here. Of course, the bars are masking hiding some of the lines here, so which is because of their different scales. So this is on the left y-axis, this is on the right y-axis, because I set the secondary y to true here. Now, let me just control the scale of the y-axis on the right by setting the range of the y-axis, right? So let me just set it to bigger, and then because it's bigger, then it's going to appear smaller, right? Because the maximum is now much bigger. So this is how we can set the range of the y-axis to control the appearance. All right, of course, here we cannot do anything about hiding these particular points, unless we want to make the bars even shorter. All right, so we can also plot the data as a candlestick chart. Of course, you know that candlestick chart, each candlestick chart is actually a summary of one day's price. So we need to pass in the open, high, low, and close price for these parameters, and then the x-axis our dates. So we just plot it, and this is our candlestick charts. We can also zoom in, zoom out, right? So this is zoom in, and we have different candlesticks, right? So you can use to analyze. Okay, so I believe that's about it, and thanks for watching. I'll see you in the next video.